Hi everyone, myself Nirmalia Kundu. I'll be presenting Cloud Model Explorer. So I'm working as a software engineer at MathWorks on the System Composer toolbox. So the main motivation for the project is model-based systems engineering and software architecture modeling is typically a collaborative activity. Models need to be accessed and updated collaboratively and uniformly. Organizations are moving to have private clouds or shared databases for their architecture artifacts. The pain points are the System Composer currently is a desktop toolbox on MATLAB, no functionality for web access of the System Composer model, no scope to share System Composer model, no scope for editing the same model by the multiple user. Objectives. As of today, the System Composer is purely a desktop toolbox independent or rather dependent on MATLAB. The main goal of the project would be to make System Composer models available on the cloud with AWS and work on System Composer models independent of MATLAB. Exporting a System Composer model to cloud, creating an export function to export a model from desktop to cloud. Importing a System Composer model from cloud, creating an import function to import any model from cloud with an appropriate user authorizations and work on it on the MATLAB. RESTful APIs for easier access of the models or basically querying the models on the web. A web app for creating a simple web app to see the models and its artifacts on the web independent of the MATLAB. The benefits. The benefits are exporting a System Composer model and its artifacts to cloud to work on System Composer models independent of the MATLAB. Importing System Composer model and its artifacts from cloud to work on System Composer models independent of the MATLAB. System Composer models and its artifacts can be accessed by any authorized user on the cloud. System Composer models can be shared between users inside and outside the organization. Editing the same System Composer model by multiple users. RESTful APIs to query any model. Web app to access model and its contents independent of the MATLAB. Technologies. Technologies mainly include the EC2 for cloud computing, processing of the System Composer models and RESTful APIs. S3 for saving the System Composer model artifacts. Document DB saving of the System Composer models as NoSQL. MATLAB for creating the functions to communicate between MATLAB and cloud. Python for creating function to communicate with the document DB. PHP for the RESTful APIs for querying the System Composer models. HTML, JS, and CSS for creating web app to access the System Composer models independent of the MATLAB. So these are the RESTful APIs which we will be using. So I've created API to get the models, a model by particular name and type, and setting the model on the web. So let's dive into a demo. So this is the Cloud Model Explorer architecture where I have the M files, which is basically the MATLAB files to import a model from cloud or exporting a model to the cloud, and also uploading artifacts to S3 and downloading artifacts from S3. So now I have the model module where I have multiple models, and ZC API is basically the RESTful APIs to get the models or the models and set the models on the cloud. The app module have the web app, which is basically to access the web access System Composer, the Cloud Model Explorer. And the DB module holds the Python code to access the AWS document DB from MATLAB and to and from MATLAB. So now let's see how does this work. So before that, what I have done is basically started EC2 instance. So this is my EC2 instance, which I have started with all the server actions and user data. So now if I show, now let's go to the document DB. So this is the Amazon document DB, which I'll be using as a NoSQL to save the System Composer models. So this is the web app that I have created to view the System Composer models on the web as a JSON so that I can use this JSON to recreate the model on the MATLAB. So let's start by exporting a model to the cloud. So this is the model that I'll be using as keyless entry architecture system. So this is the model which have multiple components, ports, and connectors. So now let's export this model. So if I export this model to the cloud, the model is being exported. So the model was exported, was successful. So now let's go to the cloud access dashboard and see. Let's go to the keyless ND architecture and let's see the components. So this is the components, the JSON structure of the components that's exported to the cloud. So if I want to see the ports, I can just use the model and the ports. The query is basically to get the model with the name interlace architecture and like type ports. So this is the JSON structure. So similarly, I can query for other requirement leaks, connections, and port interfaces. So now, since we have seen like how this is exported to the cloud, now we can import the model from the cloud into the MATLAB. So if I do model, import model from cloud, pass the model name and the EC2 server IP, the model is being imported. So if I do model, I can see the components, ports, connection, import interface, and requirements has been imported. So now I can work on it on the MATLAB. So now my future improvements include version controlling and to work on the complex queries, or basically to make complex queries to query the model on the web. Thank you.